Hi, good morning. It's Monday. Um, we're starting something new today. I'm super excited. Today we're starting section 7.2, solving systems of equations by substitution. So let's think about this for a minute. Up until now, we've been solving them by graphing them, all right? But sometimes solutions are not easy to see on a graph. Not all solutions are perfect whole numbers like 2, 2 or -3, 5. Sometimes solutions are pretty ugly. And I say that, and I feel like I'm such a total liar because all the examples you're going to be given in this section do result in pretty neat, tidy solutions, but it's more the system I'm trying to explain to you. There is another way to solve systems of equations. There's another way to find the xy point that solves both equations, and substitution is one of those ways. There's actually two ways to do it, but we're going to learn substitution in this section. Now, this first section, I'm going to call it Part A. Part A means that you are solving systems of equations and both of the equations are written in slope-intercept form. Both have been solved for y. That makes it easier. Part B will make it a little more complicated. The equations won't necessarily be solved for anything, but we will get to that fun part next week. For right now, let's look at some Pinterest posts. I like this one. I dropped my phone, so I decided to make the best of it. I know a lot of 8th grade students have broken phones, so if there's an idea, if you happen to be one of them. This one, well, I feel so manipulated. This is exactly how I read it. Here we have poor little dog. When did them kids go back to school? Aw, they wrote all over him. Poor guy. Okay, so all I have for you on the agenda today is to watch the video. I'm going to do 5 examples of how to do this. Tomorrow, the practice assignment will go live on Edge Elastic, and Thursday the quiz will go live. I'll put other videos, with other examples, but I think you're really going to like this. You guys are kind of math nerds like me, maybe a little younger. This is an example of a system of equations that can be solved by substitution. This could also be solved by graphing. You can totally cheat. I have no idea what you're doing at home. You could totally go put this in on Desmos and get the answer and not do any of this substitution stuff. But next year when you get to the high school, they're going to expect you to already know how to do this, okay? So I want to go ahead and show you how to do it with substitution, and please play along, all right? So here's what you would do. If we know that this expression is equal to y, and we know that this expression is equal to y, then we know that this expression has to be equal to this expression. And that's the basis of substitution. I'm going to take this y out, and I'm going to put x plus 3 in its place. Okay, I'm going to substitute. So if I do x plus 3 for that y right here, he's gone now, x plus 3 is in his place, equals -2x minus 15. Okay, now we just solve for x, which we can totally do. I'm very fond of saying when you go after when you have variables on both sides, it's usually easiest to go after the smaller one, and this case is true. So we're going to go after this -2x because that's smaller than a positive 1x, and we're going to add 2x to both sides. That will give me 3x plus 3 equals -15. Okay. Now to get x by itself, subtract 3 from both sides, and I will get 3x equals -18. And then I will divide both sides by 3, and I get that x is -6. All right, so I have the first part of the solution. I know the x coordinate is -6, but what's y? Well, I can find y because now I know x. So let's take the easier of the two equations. This guy here, he's pretty simple, right? Y equals x plus 3. I know x is -6, so I can substitute, there's that word again, I can substitute that -6 for x. I put the -6 where the x was, And now I have found what y is. So I have the second coordinate for my answer. And the point that solves that system of equations is -6, -3. Cool, right? I love this. I love all math, but certain parts of math I like better than others. And this is definitely a favorite of mine. I'm so sad that we didn't get to cover this in class because I would have had a great time. All right, same exact thing. In all the examples in 7.1 or 7.2 part A will have been solved for y. And so all you have to do is substitute one of the expressions for one of the y's. So let's do 8x minus 9 equals -6x plus 5. Okay. Now we're just solving for x. Go after the smaller variable, add 6 to both sides. That gives me 14x minus 9 equals 5. Add 9 to both sides. And I have 14x equals 14. I think we know that means x is 1. So I have the first coordinate, x is 1. But now I need y. Well, pick the easier of the two. This is half a dozen of one and 6 of the other, so it doesn't really matter which equation we use. I'm going to use y equals 8x minus 9. You get the same result no matter which one you pick. I'm going to substitute 1 for x. Well, 8 times 1 is 8 minus 9. Y is -1. So the solution is 1, -1. Pretty easy, right? This is super fun. The only time it gets more fun than this is when these equations are not solved for y. Then you have to solve for y and then substitute. Double the fun. Okay, example 3. All right, again, I'm going to take the 7x plus 7 and substitute it for this y. So that gives me 7x plus 7 equals 3x plus 3. Solve for x. I'll get rid of the smaller variable. I now have 4x plus 7 equals 3. Subtract 7 from both sides. I'm trying to isolate my variable term. It gives me 4x equals -4. Oh, look at that. Divide both sides by 4, and I have that x is -1. So I have my x coordinate, -1. I need my y. Well, if x is -1, I take one of these equations. Like I said before, it doesn't matter which one I pick. And I substitute -1 for x. So that's going to give me 3 times -1 plus 3. Well, 3 times -1 is -3. And -3 plus 3 is, you guessed it, 0. So the point that solves both of these equations is -1, 0. And you can totally check this. You can totally put -1, 0 in for x and y and see if you get a true statement. If you're a person who likes to check their work. I'm a little lazy when it comes to that. Example 4. I'm going to take this part here and I'm going to substitute it in for y. So I'll have -4x plus 10 equals -7x plus 16. Get rid of the smaller variable, which is -7. So I do that by adding 7 to both sides, 7x. That'll give me a positive 3x over here, plus 10 equals 16. Subtract 10 from both sides, and I get 3x equals 6. And I think we all know that means x is 2. So x is 2. And now I want to substitute in, doesn't matter which one. I guess I can use this guy here. If I'm going to use y equals -4x plus 10, the one you can just barely see because I scribbled all over it, I substitute 2 for the x. So that gives me -4 times 2 plus 10. So y equals -8 plus 10. So y is 2. Pretty cool, right? I like it. By the way, your secret word for having watched today's video is cool math. I guess it's not a word. Your secret words. If you comment cool math, I'll know you watched the video. Right? And the last example I have I'm going to take negative 2x minus 3, and I'm going to substitute it for y. Negative 2x minus 3 equals 4x plus 3. Solving for x, get rid of the smaller variable so that we have all of our variables on one side. Gives me negative 3 equals 6x plus 3. Subtract 3 from both sides, and I get negative 6 equals 6x. If I divide both sides by 6, I find that x is negative 1. So on my xy coordinate point, x is negative 1, but what's y? Well, we need one of these equations. We'll use the 2, 3 one. Negative 2x minus 3. X is negative 1, so I have negative 2 times negative 1 minus 3. That gives me y equals negative times a negative is a positive. And that means that y is also negative 1. So the xy coordinate point where these two lines would intersect is negative 1, negative 1. I don't know about you, but I am really excited about this section. I love solving for x and solving for y, and this is just going to give us a chance to do that over and over again. So tomorrow, look for the practice to pop up in Edge Elastic. It's 10 questions. Solve them just like this. And remember, comment cool math, and I'll know you watched the video. All right? Have a good Monday. I'll see you tomorrow.